Welcome to Mathematics Study channel. In the last class, we discussed about determinant. We have already completed exercise 4.5. Today, we are going to solve exercise 4.6. Before starting exercise 4.6, if you not subscribe my channel, then subscribe my channel for latest notification and upcoming videos. Okay, now let's start. So first of all, I write some examples here. Let a1x plus b1y plus c1z equal to d1. It is an equation, and a2x plus b2y plus c2z equal to d2, and a3x plus b3y plus c3z equal to d3. We write here three equations: a1x plus b1y plus c1z equal to d1, a2x plus b2y plus c2z equal to d2, and a3x plus b3y plus c3z equal to d3. These equation how to write in a metric form. Okay, in the matrix form. This system of equation can be written. This system of equation, there are three equations. So this system of equation, can be written as how? Ax equal to b. Ax equal to b, where a is what and x is what and b is what. Where a equal to, we write a equal to what? You write a1, b1 and c1. a1, b1, c1, a2, b2 and c2, a3, b3 and this is c3. That means in a, coefficient of x, y, z, in second line coefficient of x, y, z, in third line coefficient of x, y, z, and x is what? Where x equal to, you write here x, y, z. The variables are x, y, z, and what is b? B are the constant. Okay, b, what is b? B are the constant. B are what? B are d1, d2 and d3. d1, d2 and d3. So this is the, if the equation is given, then the given equation can be written in the matrix form in this way: ax equal to b. Is it clear? Okay. Now we are going to check the given equation or given system of equation is consistent or not. How to check it? The given system of equation are consistent or not. For this, the given system of equation are consistent or inconsistent. How to check it? The given system of equation is consistent or inconsistent according as, formula मिला कि according as number one, if determinant of a not equal to 0, if first of all what we check, if determinant of a not equal to 0, then system of equation is consistent. Then the system of equation is consistent, then the consistent, okay, then the given equation is consistent and has unique solution, that is if যদি determinant of l ভ্যালুটো কি নহয় 0 নহয় তেতিয়াহলে যেটো সিস্টেম অফ ইকুয়েশন দিয়া থাকিব এই ইকুয়েশনটো কি হ'ব কনসিস্টেন্ট হ'ব আৰু it has unique solution আৰু ইয়াৰ কি অদ্বিতীয় সমাধান থাকিব অদ্বিতীয় মিন্স x আৰু y ৰ কাৰণে যিকোনো নিৰ্দিষ্ট এটা মানৰ কাৰণে কি হ'ব সমীকৰণটো সঁচা হ'ব ওকে and condition number 2 what is condition number 2 condition number 2 is what the condition number 2 is determinant of a equal 0 if determinant of a equal 0 then if determinant of a equal to 0 then it is singular okay if determinant of a equal to 0 and adjoints of a into b adjoints of a how to find adjoints of a we know it okay so if determinant of a equal to 0 and adjoint of a into b not equal to 0 but the product of adjoints of a and b not equal to 0 then there exists no solution then there exists no solution then there exists no solution there exists no solution then there exists no solution যদি determinant of a equal to 0 আৰু adjoint of a into b not equal যদি 0 হয় then there is no solution যদি কোনো solution না থাকে that is we said it is inconsistent that is inconsistent number 3 is what if determinant of a equal to 0 if determinant of a equal to 0 if determinant of a equal to 0 and adjoints of a into b is also equal to 0 if determinant of a equal to 0 and adjoint of a into b is also equal to 0 then what do we get then the system of equation is consistent then the system of equation is consistent and what and has a what and has a infinite number of solution and has a infinite number of solution this is the condition okay the first condition is what if 3 or 2 okay if 3 or 2 equation is given then if determinant of a not equal to 0 then the system of equation is what consistent that is it has a unique solution and number 2 is what if determinant of a equal to 0 and adjoint of a into b not equal to 0 then there exists no solution that is it is inconsistent number 3 is what number 3 is if determinant of a equal to 0 and adjoint of a into b is also equal to 0 then the system of equation is consistent and has a infinite number of solutions now let's start to solve exercise 4.6 exercise 4.6 the question number 1 examine the consistency of the system of equation question number 1 to 6 it is very simple we already done here okay so question number 1 is what is question number 1 so question number 1 is it is given question number 1 given that what is given system of equation are the equation are what x plus 2y equal to 2 x plus 2y equal to 2, and second equation is 2x plus 3y. 2x plus 3y equal to what? 2x plus 3y equal to 3. The first of all, this given equation can be written in the matrix form. Okay, the given system of equation, first of all you write here, the given system of equation can be written as ax equal to b, where you write a equal to what? Where you write a is what? Coefficient of x and y. Coefficient of x and y. This is 1, this is 2, this is 2, and this is 3. This is a. And x is what? X is variables. How many variables in the given equation? There are two variables. Variables are x and y. And b is what? And b equal to, b is what? 2 and 3. B is 2 and 3. Go. So first of all, what we have to done here? We have to check here determinant of a. So for the consistency, first of all we check here determinant of a equal to what? Now determinant of a. So determinant of a equal to what? Determinant of a equal to, right here, determinant of this 1, 2, 2 and 3. This is determinant of a. This is equal to what? This is equal to 1 into 3 is 3 minus 2 into 2 is 4. This is equal to what? This is equal to minus 1. And minus 1 not equal to 0. This is not equal to 0. Since determinant of a not equal to 0, since determinant of a not equal to 0, so the given system of equation is what? Consistent. Okay, this is clear. Now we are going to solve question number 3. Okay, question number 3 is what is given? The given equations are given. What is given? Equations are x plus 3y equal to 5. X plus 3y equal to 5. And second equation is what? Second equation is 2x plus 6y. 2x plus 6y equal to 8. So this equation can be written as, this equation can be written as, how to written as ax equal to b, where a equal to what? A equal to what? A equal to coefficient of x and y. Coefficient of x is 1, this is 3, this is 2, and this is 6. Okay, and x is what? Variable x and y. And b is equal to what? B is equal to 5, 8. This is b. Okay, so now for the consistent, what we have to do here? So for the consistent, first of all we check determinant of a. So determinant of a is what? Determinant of a is this 1, 3, 2 and 6. This is equal to what? 1 into 6 is 6 minus 6, which is equal to 0. So determinant of a equal to 0. Therefore, since determinant of a equal to 0, then what we get? Then a is singular matrix. Since determinant of a equal to 0, so a is a singular matrix. So if determinant of a equal to 0, then we cannot say about the consistent of the given system of equation. So if determinant of a equal to 0, then we are going to find, then we have to find adjoints of a into b. So first of all, for find the adjoint, we have, first of all, we find the cofactor. Now cofactor of a are, cofactor of a are So cofactor of A are what? A11 is what? A11 is 6. A12. A12 is what? A12 is this cancel. This is minus 2. Sign should be negative here. And A21 sign should be negative. A21 cancelling by first column and second row. Then this is 3. A22 equal to what? A22 equal to cancelling by second row and second column, then it is 1. Okay. Therefore, adjoint of A equal to what? Adjoint of A is 6 minus 2 minus 3 1 times this. Okay. This is equal to, this can be written as 6 minus 2 minus 3. This is 1. This is adjoint of A. Now we have to check adjoint of A into B. Okay. Now adjoint of A into B. Adjoint of A into B. Adjoint of A is what? Adjoint of A is 6 minus 3 minus 2 and 1 into B. B is what? B is already given here 5 and 8. So write here 5. This is 8. So what do we get here? So this is equal to what? If we multiplying first row by first column, then what do we get? This multiplying with this is 30. Okay. And 30, this is minus is 24. Okay. Again, second row by first column, then if we multiplying this is minus 10. This is plus 8. This is equal to what? This is equal to, we get here. So 30 minus 24 is 6 and minus 10 plus 8 is equal to minus 2. So what do we get? The adjoint of A into B equal to what? Adjoint of A into B equal to 6 minus 2, which is not equal to 0. So in which condition? So how do we say here? Since the determinant of A equal to 0 but adjoint of A into B not equal to 0, then how do we say here? Hence this system of equation is inconsistent. Okay, hence what do we have? See, therefore we have determinant of A equal to 0 and adjoint of A into B not equal to 0. Hence the system of equation is inconsistent. Okay. Now we are going to solve question number 7. Okay, and question number 4, 5, 6 are same as question number 1 and 3. So we are going to now solve question number 7. The question number 7 is what? Solve the following system of linear equation using matrix method. Okay. In earlier class, how to solve linear equation, we already got it. But here we are going to solve linear equation by using matrix method. Okay. So how to solve this? It is a very simple. First of all, question number 6. I am going to solve question number 6. First of all, you write the given equation. So given equation is what? Given equation is 5x plus 2y equal to 4. 5x plus 2y equal to 4. And second equation is what? 7x plus 3y equal to 5. 7x plus 3y is equal to 5. This is the given equation. Okay. It is very simple. So this equation can be written as in the matrix form, that this equation can be written as x equal to b. Okay. What is x equal to b? Where a equal to what? You know. The a equal to what? A equal to coefficient of x and y are. Then this is 5, this is 2, 7 and this is 3. Okay. And b is right here. B equal to what? B is what? B is coefficient. This is 4 and 5 and x. X is what? X equal to variable x and y. So first of all, we check a determinant of A, because it is singular or non-singular. We first of all you check here. So determinant of A equal to what? Determinant of A is right here 5, 2, 7 and 3. This is equal to 5 is 3, 15 minus 14. This is equal to 1, which is not equal to 0. Since determinant of A not equal to 0, since determinant of A not equal to 0, so A inverse exists. Okay, so A inverse exists. So A inverse is exist. Okay, so since A inverse exists, so the given system of equation is consistent or not? It is consistent because determinant of A not equal to 0. So the given system of equation is consistent and what? And has unique solution by what? By what x equal to A inverse of B. How to write this? Because if Ax equal to B, then if you write in this way, Ax equal to B can be written as, if we x equal to then B by A. Okay, this can be written as x equal to A inverse of B. This is clear. Now for A inverse, we first of all we find the cofactor. Okay, the cofactor of AR, this is A11 equal to what? A11 is 3, A12 sign should be negative here, cancelling by first row and second column. This is 7. Okay, A21 sign should be negative here, this is minus 2, and A22 equal to what? A22 is 5. This is okay. Therefore A inverse equal to what? A inverse equal to, formula is what? 1 by determinant of A into what? Adjoint of plus A inverse equal to what? 1 by determinant of A is what? Determinant of A is, I think determinant of A is the value of determinant of which first of all we check here. Our question number 7, determinant of A is 1. Okay, so determinant of A is 1, right here 1. Okay, so adjoint of A is what? So 3 minus 7 minus 2 5 henceforth. This can be written as A inverse equal to what? 3 minus 7 minus 2, this is 5. This is the A inverse. Now we are going to find x equal to A inverse B inverse. So right here, therefore x equal to A inverse of B. So x is equal to what? X equal to xy. This is equal to A inverse. A inverse is 3 minus 2 minus 7 and 5. And B is what? B is what? 4 and 5. Okay, B is 4 and 5. So this is equal to what? If we multiplying, then what we get? 12 minus 10, and this is minus 28 plus 25. This is equal to, this can be written as 12 minus, this is 2 and this is minus 3. So what we get? We have here x, y. Therefore x equal to 2 and y equal to minus 3. Therefore right here, therefore x equal to 2 and y equal to minus 3. This is the answer. Now we are going to solve question number 8. So question number 8, first of all you write the given equation. Given equation are, what are the given equation? Given equation are 2x minus y equal minus 2. So right here 2x minus y equal to minus 2. Okay, and second equation 3x plus 4y equal to 3. 3x plus 4y equal to 3. This equation can be written as, like this is can be, this equation can be written as ax equal to b. Okay, where a equal to what? A equal to 2 minus 1 3 and 4, x equal xy, and y equal to what? And y, not y, sorry, this is b, and b equal to minus 2 3. Okay, now check determinant of a. Determinant of a equal to what? 8 minus 3 minus minus plus 3 equal to 11. This is not equal to 0. Therefore a is what? Singular. A is singular matrix. Okay, since a is a singular matrix, then it has a what? Sorry, not singular, it is non-singular. Therefore a is a non-singular. Since determinant of a not equal to 0, so a is a non-singular matrix. So since a is a non-singular matrix, therefore a inverse is exist. Therefore a inverse exists and it is consistent, and this given equation has a unique solution. So therefore you write here x equal to what? A inverse of b. So now we are going to find the cofactor. Now cofactors of a are, what is the cofactor? A11 equal to what? A11 equal to 4, A12 equal to, sign should be negative here, so cancelling by first row and second column, then what do we get? This is minus 3, and A21 cancelling by second row and first column, second row and first column, then this is minus 1, so sign should be negative and this is plus 1. Okay, and A22 equal to, this is also 2. Okay, therefore A inverse equal to 1 by determinant of A. 1 by determinant of A is 11, to write directly right here A. Okay, and adjoint of A is what? Adjoint of A is 4 minus 3 1 2 transpose. Okay, so this is equal to, that implies A inverse equal to 1 by 11 into what? Into 4, this is minus 3, this is 1 and this is 2. This can be written as A inverse equal to, this is multiplying by then 4 by 11, 1 by 11, this is minus 3 by 11, and this is 2 by 11. Okay, this is the A inverse. Now therefore x equal to what? X equal to A inverse of b. So this is right here, x is what? X is xy. So A inverse is, already we have A inverse is 11 by 4 by 11 minus 3 by 11 and 1 by 11, and this is 2 by 11 into b. What is b? B is what? B is minus 2 3. Okay, so b is minus 2 and 3. Now multiplying, then we get the result. This is equal to, if we multiplying this with this, then what we get? This is minus 8 by 11, this is plus 3 by 11, and this multiplying with this, then this is minus is plus 6 by 11 plus 6 by 11, then this is equal to what? So if we taking LCM is 11, then what we get? This is minus 8 plus 3, and this is 6 plus 6 12, okay, by 11. Then this is equal to what we find here? Minus 5 by 11, and this is 12 by 11. So x equal to what? X equal to, therefore x is equal what? Minus 5 by 11, and y equal to what? Y equal to 12 by 11. 12 by 11. We are going to solve question number 11. So question number 11 is what? The given equation are, so first of all we write the equation 2x plus y plus z equal to 1. 2x plus y plus z equal to 1. And second equation is what? Second equation, x minus 2y, x minus 2y minus z equal 3 by 2. This can be written as, if we multiplying by 2, then this is 2x minus 4y minus 2z equal to 3. And lastly, last equation is what? Last equation is, x is not given here, so this is last equation. You write here 0 into x, okay, 0 into x plus 3y minus what? Minus 5z equal to 9. So this equation can be written as, this equation can be written as ax equal to b, where a equal to, what is a? Where a equal to coefficient of x, y and z. So a equal to what? 2, 1, 2, 1, 1, and second row is what? Second row is 2, minus 4 and minus 2, and third row is 0, this is 3, and this is minus 5. This is, and x equal to y, x equal to x, y, z, and b equal to what? b equal to constant. What are the constant? 1, 3 and 9. So write here 1, 3, this is 9, this is the b. Okay, now first of all we check the determinant of a. Determinant of a equal to what? If determinant of a equal to 0, then there is nothing to prove here. So determinant of a, first of all, this is 2. Okay, then cancelling by first coulomb, then this is 20. Okay, this is minus is plus 6. Again this one is minus, here give here minus, here is 1. Okay, cancelling by first row and second coulomb, then cancelling by first row and second coulomb, and then what do we get? Then 2 into minus 5 is minus 10. Okay, this is minus 0 into what? 0 into minus 2, this is also 0. Okay, and lastly this is plus, this is 1. Okay, so 1 into what? 1 into cancelling by first row and third coulomb, then 6 minus 0, this is 6. Then what do we get? This is equal to 2 into 26, this is plus 10 and plus 6. This is equal to what? We have, this is 52 plus 16, this is equal to 68. Okay, the value of this is 68, which is not equal to 0. So 68 not equal to 0. Determinant of a not equal to 0. Okay, since determinant of a not equal to 0, so a inverse exists. So a inverse exists, that means it is consistent and it has a unique solution. So how to find the unique solution? For unique solution, we find the cofactor over. Therefore, cofactor, we are going to find the cofactor of AR. So cofactor are what? A11. First of all, A11. A11 cofactor T, this minus this. So what we get here? Cofactor of A11 is, this is 20. Okay, minus is plus 6. So A11 is what? A11 is 26. And next A12. That means sign should be negative here. So give here negative. So cancelling by this and this, then what do we get? 10. Okay, minus 10 into 0. So this is minus 10. That means this is plus 10. And lastly A13. A13 equal to what? Cancelling by first and third coulomb, then what do we get? 6 minus 0. This is only 6. So A21 sign should be negative here. So this one, so cancelling by first coulomb and second row, cancelling by first coulomb and second row, then first coulomb and second row, then remaining is 1, 1, 3 and 5. 1 into minus 5 is minus 5. Right here minus 5 and minus 3, and this is minus 3. The value of this is what? Value of this is plus 8. Add 2 2. Add 2 2. Okay. Add 2 2 is what? Cancelling by second row and second column. If we cancelling by second row and second column, then remaining is 2 into 5 is minus 10. Minus 10. Okay. 2 into minus 5 is minus 10. Then this is 0. So lastly, a 2 3 sign should be negative here. Okay. Minus, give here minus. Then cancelling by this row and this column. Then what we get? 2 1 0 3. Then what we get? 6 minus 0. So this is minus 6. And lastly, a 3 1. A 3 1. A 3 1 cancelling by this and this. Then this is minus 2. Minus minus is plus 4. Then 4 minus 2 is, this is 2. So a 3 2 sign should be negative here. Cancelling by third row and second column. Then 2 into 2 minus 4 minus 2. Okay. Minus 4 and minus 2 is minus 6. And a 3 3. A 3 3 equal to what? Cancelling by this row and this column. This is minus 8 minus 2. This is equal to what? Minus 8 and minus 2 is minus 10. This is minus 10. So this is equal to what? So if we, when you find cofactor of A32, A32 is cancelling by this row and this row column, then what we get? This is minus 4 minus 2. This is minus 6. So sign should be negative here. To give here negative, then A32 is what? Plus 6. Okay. Therefore A inverse equal to 1 by determinant of A into what? Adjoint of A. So this is equal to what? So determinant of A is what? 1 by determinant of A is 68 into adjoint of A. Adjoint of A is what? This is adjoint of A. So this is 26 right here. 26 10 6 10 and this is 6. Second row is what? Second row is 8 minus 10 minus 6. 8 minus 10 and minus 6. And third row is 2 6 minus 10. 10 scores. Okay. This is equal to, you can write 1 by 68 whole into what? 26 10 and this is 6 8. Not it, sorry. By interchanging the row and column, then what we get? This is 26, this is 10 and this is 6. Okay, second row is second column 8 minus 10 and this is minus 6 and this is 2, 6 and minus 10. This is A inverse. Now we are going to find X equal to A inverse of B. So X equal to A inverse of B equal to what? X equal to A inverse is what? A inverse is given here. So right here A inverse is what? 1 by 68 into 26 10 and this is 6. This is 8 minus 10 and minus 6 and this is 2 6 minus 10 is multiplying with what? B. What is B? We write here B is 1 3 and 9. 1 3 and this is 9. Then if we multiply, then what we get? That implies X is equal to what? X equal to X, Y and Z. This is equal to, if we 1 by 68, if we multiplying, then what we get? 26 into 1 is 26 plus 3 is 8, 24 plus 18. Okay. And second row first column, this is 10 minus 30 plus 54. And lastly, third row first column is, this is 6 minus 3 is 6 18 minus 9 0. This is equal to what? 1 by 68 whole into, if we adding this, then what we get? 6 4 10. Okay, 10 plus 8, this is also 68. If we add this, then what we get? 10 minus 30 is minus 28 plus 54. That means this is equal to 34. And here is 6 minus 18 minus 90. That means if we add this, then we get 108. 108 minus 6 is minus 102. Now dividing each term by 68, then what we get? We get here, this is 1, okay, then 34 by this is 1 by 2, and this one is minus 3 by what? Minus 3 by, I think minus 3 by 2, okay, because if we cancelling by 34, then 34 by 3 is 102 and 34 by 2 is 68. Then what we get? Therefore x equal to, you write here, so x equal to what? 1, y equal to, we have y equal to 1 by 2 and z equal to minus 3 by 2. This is the ভিডিওটো কেনেকুৱা লাগিছে কমেন্টত জনাব। যদি ভাল লাগে তেন্তে লাইক আৰু শেয়াৰ কৰিব আৰু এনে ধৰণৰ নতুন নতুন ভিডিও পাবৰ কাৰণে চেনেলটো সাবস্ক্ৰাইব কৰিব।